Hi, this is Mario Lento, Product Specialist at Berkeley Process Control. This video provides a brief introduction of the operation of the Berkeley AWS. It is not intended to provide operator training, which would take a bit longer. First, I want to say that the AWS is extremely easy to use. A single operator can perform all welding needed to seal a spent fuel canister. Other canister welding systems require multiple operators, resulting in much higher labor costs both short-term and especially over the system's lifetime. Berkeley's AWS is also an advanced tool for the welding engineer, making it easy to create and modify sophisticated weld recipes. However, the video's primary focus is on how to use the AWS as a welding operator. The Berkeley AWS is simple to integrate into spent fuel operations. It's easy to set up and it's even easier to operate. The remote console's operator displays and controls are intuitively simple. High-quality video feeds display leading and trailing views of the weld. Here are the steps required to weld qualification and practice coupons completely using the AWS's remote console. From the console's main screen, we select Operations and then Teach. Next, select Qualification Weld Program and the Start Teach button. The AWS expects a standard qualification weld coupon at some nominal location and so moves to that expected start point. Here, the remote operator uses the toggles to jog the torch to the desired weld start location. After remotely jogging the torch to the actual start point, the operator presses the flashing green Continue button and accepts that point. The torch automatically proceeds to the second point. After remotely fine-tuning the second point, you're finished teaching the weld path. Okay, so let's weld that qualification coupon. First, we select the Operation panel. Then, we select Weld Plasma Cut. Since we just taught the qualification coupon, the AWS takes us to the Qualification Weld program. After selecting our choice, we can either weld or perform a dry run. We'll select Weld and then Start. Now, the torch moves to the weld start location and waits for us to make adjustments before taking over and beginning the weld. After lowering the torch, we push the flashing green Continue button and welding begins. Note that the AWS automatically pre-purges with inert gas and then ramps current, voltage, travel speed, and oscillation before synchronizing the wire feed with the puddle. Also note that each of the pre-programmed steps will overlap to tie in the weld strings. All primary and background parameters are automatically managed to create a perfect weld each time. The intuitive interface, however, makes it simple to fine-tune any of the pre-programmed parameters on the fly. These include oscillation width, both primary and background current, primary and background voltage, wire feed, and primary and background travel rates. At the end of each weld string, the AWS automatically ramps down current, voltage, travel, and oscillation, and then it pulls back the wire before the puddle solidifies. It also completes the post-purge of the inert gas. Now, let's explore the canister cover welding. To save operator time and dose near the canister, the operator uses a remote crane to place the AWS within a few inches of the center of the lid. Let's teach the outer cover. From the console's main screen, we select Operations and then Teach. Next, we select the outer cover weld program and press the Start Teach button. As with qualification coupon welding, the AWS assists the operator by approximately positioning the torch at each of the nominal teach points. The operator fine-tunes the first teach point, then accepts that point by pushing the Continue button. The torch then moves to the next teach point. Of course, this is all done from the remote operating console, not at the canister. After the 8th and final point is taught, the AWS calculates the nominal weld path. Teaching quickly enables the AWS to automatically track the torch's complex path determined by oscillation width, oscillation frequency, torch tilt and twist angles, travel speeds, and torch height. Now let's weld the outer lid. Again, we select the operation panel, and then weld plasma cut. Once in the outer lid program, we can see its pre-programmed steps. Parameters for each of the 8 tack welds allow us to seamlessly tack weld the cover plate to the canister. Other pre-programmed steps include the 8 root fills, which automatically tie into the tacks, fill passes, inspection passes, hot passes, and cap weld passes. Since this canister mockup is partially welded, let's choose one of the fill pass steps. Once we've selected the step we're going to execute, in this case the fill pass, we can choose dry run or weld. Now let's start laying welds on this canister. The torch moves to the weld start location and again waits for us to make adjustments. After lowering the torch to the desired start point, we push the flashing green continue button and welding begins. Again, the pre-programmed recipe, in this case fill pass, includes all of the parameters to create a perfect weld each time. The intuitive interface makes it simple to fine-tune virtually any of the pre-programmed parameters on the fly. These include oscillation width, primary and background current, voltage, wire feed rates, and travel speeds. Here you can see we're adjusting the oscillation width, which can be used to bridge a gap or account for varying weld groove widths. The AWS can be interrupted at any time during welding, after which it can automatically tie in where you left off. With the AWS, weld quality is more of a science than an art, since control of all parameters is automated to the maximum extent. In closing, the Berkeley Automated Welding System is a highly capable solution to the needs of dry storage canister closures. It integrates comprehensive machine and welding process automation to reduce labor costs, reduce radiation exposure, deliver weld quality and consistency, and assure productivity. It has earned its reputation for reliable, hassle-free operation. Please contact me, Mario Lento at Berkeley Process Control, if you'd like to discuss spent fuel canister or other automated welding applications. Thank you.